A stone is thrown from the edge of a roof 820 feet above the ground at a speed of 16 feet per second. Part A of this question is we want to find the height of the stone after 2 seconds. So, some information that we're going to need for this. We need to know what the acceleration is. Now, because we're talking about gravity and we're throwing it off a roof, acceleration, when we're talking about gravity and we're doing it in terms of feet per second, is negative 32 feet per second squared. Some other information that we're going to need to know that we can pick out from the information given in the problem. We know that since the initial height of the stone is going to be 825, because that's where it's thrown off from, 825 feet off the ground, off the top of the roof, we know that the initial value of the height function is going to be 825. Whoops. So that's our initial value for the height. We plug in 0 seconds and we should get out 825 feet up. Okay, now another thing that we're picking out here from what's given to us is the initial speed. So when we plug in 0 into the velocity function, so when time is 0 for the velocity function, we should get out 16 feet per second. So all this information is important and we're going to use it when we're finding our height function. So we have to find our height function, our h of t, because the question wants us to find the height after 2 seconds. Once we find our height function, we can plug in 2 seconds and find the height after 2 seconds. So that's our goal. Our goal is to find h of t. Now, given the information to us, what we can do is we can use the idea of the antiderivative and we can work backwards. So if we think about what we do when we're going forwards, if I take the height function and I find the derivative, that's going to give me the velocity function. Then if I take the velocity function and find the derivative, that gives us the acceleration function. So if I start with the acceleration function and do the antiderivative, that should give me the velocity. And then if I have the velocity function and I do the antiderivative again, that should give me the height function. So we're going to start with the acceleration function and find the antiderivative twice. That's the goal. So our acceleration, since we're talking about gravity here, is negative 32, and that's feet per second squared. The negative is in there because we're talking about gravity, which is pulling us down. So if I find the antiderivative for this acceleration function and we think backwards, the velocity function is going to be negative 32t plus our constant. So now we have a general family of functions for the velocity. If I want a specific function, I need to know what that value of our constant is. So we're going to use our initial value up here as a point to plug in so we can solve for our constant. So since we know that our initial value for velocity is 16, that means when time is 0 seconds, the velocity is 16. So I'm going to plug that in here. So I should have 16 is equal to negative 32 times 0 plus the constant, which means the constant is 16. So now we have our specific velocity function. So we know that the velocity function is negative 32t plus 16. So now we can work backwards again and take the antiderivative again to find the height function. So when I take the antiderivative of negative 32t plus 16, I'm going to get negative 32t squared divided by 2. And that's because when we take the derivative, we bring the exponent down in front and we decrease the exponent by 1. So now when we work backwards and do the antiderivative, I want to add 1 to the exponent and divide by that exponent. And so now when I do the antiderivative of 16, I get 16t, and then I have a plus constant. I can rewrite that negative 32 divided by 2 as negative 16. So we have our family of functions for the height function. So now we need to use more information to specifically find the value of c. So that's where this comes in. We're going to use our initial value for the height. I know that for the height function, when time is 0, the height is 825. So if I plug in 0 here, and I know that that should be equal to 825. This goes away because of 0. This goes away because of 0. And then I get that my constant is 825. So now I have my specific height function, which was the goal of our question. We found that our height function is going to be negative 16t squared plus 16t plus 825. So now if we go back and think about what the question was asking us, it says find the height after 2 seconds. So I'm going to plug in 2 for t. So I have negative 16 2 squared plus 16 times 2 plus 825. And when I work that out, I'm going to get that my height is, 793 feet. So if I think about what that looks like, here's the building, here's the ground, here's the stone that gets thrown off the building. This is at time equals 0, and then it comes up, and then it starts to fall because of gravity. After 2 seconds, the stone might be right here at 793 feet. And we know that the height of the building is 825 feet. Okay, let's look at the next part of this question. We've done the majority of the work now. This was the harder part where we had to derive our height function. Okay, for part B, it wants to know, when does the stone hit the ground? All right, so when the stone hits the ground, I know that my height, whatever that value of t is for the time, that height should be 0 feet. So what we want to do is we want to set the height function equal to 0 and find t, the time when it hits. So our height function is going to be set equal to 0. So now we have a quadratic to solve. So you can use quadratic formula or whatever method you want to use to solve that. But because it's a quadratic, what's going to happen is you're going to get 2 answers. Now, because we're going to get 2 answers, because you get, when you take the square root and you do the quadratic formula, you're going to get plus or minus. So you're going to get 2 answers. So if you think about, let me do this in a different color. Let's do this. Okay, if you think about this quadratic, here's my height function. We're only looking at it because it makes sense with the problem, starting from here to here. But when we look at the graph of a quadratic, it's a parabola. So we're going to get an answer here, and we're going to get an answer here. So we want to pick the answer that's positive that comes out from the building. So when I solve that quadratic, I'm going to get 2 answers. The answer that's going to make sense within the context of this problem is going to be 7.0 6980900244444. So just remember, because we're solving a quadratic, we're going to get two answers, but we're going to choose the value of x that makes sense in the context of this problem. We're starting at t equals 0 here, so you want to think of this as the origin. So the other value that you get is going to be negative. So the part C of this question says, what is the velocity of the stone, let's see, when it hits the ground? So because we want to find the velocity, we're going to use our velocity function. And the velocity function that we found was that we have v of t is equal to negative 32t plus 16. We know that the time when it hits the ground is this. We just found it. It's approximately 7.698 seconds. So what you're going to do is you're going to plug in this x value here when it hits the ground, and you're going to plug it into your velocity function. And let's see, when you do that, you're going to get negative 230.33888078221. And because this is velocity, this is going to be feet per second. And I should have put that up here and labeled this. This is in seconds. Now, the velocity is showing as negative because it's moving in the negative direction. As we trace that stone as it comes this way, when it's at that point of 2 seconds, it's heading downward. So just remember, when you're talking about velocity and speed, there are two different things. Speed is the absolute value of velocity. Speed tells you how fast you're going, but velocity tells you how fast you're going and the direction based on the sign. So in this case, I know my speed is about 230 feet per second, but my velocity is negative 230 feet per second because we know that the stone is falling and is going in the negative direction.